Hey Jay-Ison, could you give me the intro to this video?
Hello everyone, and welcome back to the channel. Today we're diving into the world of AI with the one and only Jai-Sun. You might be wondering, who is this Jai character, and why should I care? Well, imagine you're in a conversation and you can't respond verbally. It's like being a goldfish in a world of talkers. Jai-Sun is about to change that, enabling you to hold conversations entirely through speech. So, let's get into it.
Nice work. Hey there, Limit here. Welcome back to another part in our series building out the prototype for our AI VTuber. We're finally getting close to the point where it has all the core features needed for us to fully interact with it. And one of those core features is speech. We already covered response generation and actually speaking in previous parts, but we're missing the part where we're the ones speaking. And to do that, we need to perform transcription. This is the process of taking spoken words and writing it down in text. Again, this tech is nothing new, but again, it's been massively improved by recent innovations in AI. Unlike text-to-text and text-to-speech, we're not going to be exploring many options this time, simply because the AI models for transcription are so easy to run directly on your machine with consumer hardware. So I guess for once I can get off with making a shorter video. So let's get straight into it. I had no idea what was going on inside of the AI transcription space. I have no clue where to start, I have no clue where to begin. Let's just look on Hugging Face. But I have heard of a model called Whisper. I wasn't sure what it was for, but I had a feeling it might be something for transcription. And would you look at that? I found it under the speech recognition section in Hugging Face. This section contains all the models capable of doing transcription and other audio identification stuff, but we only really need to look at Whisper. It's pretty much the only one people use, and for good reason. Not only is it one of the few things from OpenAI that's actually open, but it's also overly capable at transcription related tasks. They bet it can transcribe speech no matter how noisy or distorted it is, and sure enough it can. But even better is that they have this turbo version, which is a fine-tuned version of their largest model, so it can operate with half the size, but 8 times the speed for about the same result. So I guess there's nothing more than to just give it a try. Just like their API, OpenAI also has a package that lets us easily work with their Whisper model. It does everything from download the model onto your system to running it and interfacing with it. So there isn't much code to get it working, and I took all of this from their GitHub README. We can select which model of Whisper we want, in our case Turbo, and just give it a WAV file with some speech in it to work. Hello, my name's Limit. We're testing out the new Whisper large V3 Turbo model, whatever the fuck it's called. Here's some claps. Now transcribe. Super simple. Now let's stick it in our bot. So I just had a thought. How do we know when we finish talking? No, not we as in people listening. I mean the code. Here's the first problem. With how I implemented voice call recording right now, I have to manually run these commands to start and stop recording. So now I need to reprogram this, so starting and stopping recording is done automatically. But here's the next problem. I don't get valid audio data until I stop recording. But the moment I stop recording, I can no longer reuse the sync to continue recording if we don't think it's a complete line of dialogue. Oh, it's royally fucked. So I need to stop recording to know when to stop recording. Kind of an unsolvable paradox. I'm surprised PyCord has no way of just stopping the recording or taking out the audio data intermittently. I could probably do it myself with a little bit of work, but let me think if there's a better and easier solution. So I thought to myself for a bit longer and came up with these solutions. The first one is to train an AI to detect the end of a line of dialogue from a stream of incoming audio. That's more data than I'd like to create. And there seems to be no foundation models on Hugging Face. So option 2 then. On every pause, we can transcribe what we've heard so far, send that to our text-to-text model to get a response. Well, that wouldn't work because I'm slow in the head and need to pause a lot when I speak. Okay, well what if we train the text-to-text model to decide whether it should respond yet or just await? Wait, that's actually a good option. And it will help our model in other situations, like when you aren't typing in full sentences in texting mode, because we all have that one friend who texts one word at a time. That's great, except for the fact that it doesn't address the problem of when to stop, because we need audio data to detect a pause in the first place. Oh, but when I speak and pause in Discord, the green ring appears and disappears respectively, so there must be some event that signals when I am and am not speaking. And I can use the event for when the green ring disappears to start a fixed timer that will stop the recording when I'm no longer talking after like a second or so. This adds some fixed latency, but I can make the timer reasonably short so we don't perceive much of a difference. I just gotta search for this event and it's not here. Okay. maybe I'm just not looking hard enough. So I looked online for some posts where people are streaming audio data from Discord into files, because that seems like something that would be talked about. And sure enough, I found this extension that does exactly this. But it's a discord.py extension, and discord.py is not PyCord, which is what we've built our Discord bot with. However, I feel like I remember reading somewhere that PyCord was made to be interchangeable with Discord.py. Like, PyCord uses the same import aliases and even has extensions of its own in the same vein. So I thought maybe I could use this Discord Py extension with PyCord instead. And I tried just that. And well, the extension has Discord Py as a dependency, and installing it defaults to using that instead of PyCord. Not only that, but PyCord is not actually interchangeable with Discord Py entirely, since there are a lot of functions that don't exist between the two. And quite frankly, I don't want to fork another project and provide changes to work with my implementation, kinda like how I did with the RVC project. So after trying in desperation to see if I could force the project to work, I said fuck you to PyCord and refactored my entire project to use Discord Py instead. Okay, I didn't just F off because I was frustrated. It turns out PyCord is actually a maintained fork of Discord Py. That's why there are so many similarities between the two. And I only use PyCord in 2 places, so it shouldn't be too hard to make the switch. And it seems that we have more control over the incoming audio data, especially if we use this extension with Discord Py. So I made the switch. And yeah, for the most part, it was just a bunch of variable changes. But the biggest problem I faced was how it handles commands. In my original implementation with PyCord, I organized everything into cogs and everything registered using those cogs. The same concept also exists in Discord Py, but there's a caveat. JISON has no attribute add cog. Oh shit. Where the fuck did bot come from? They only exist for command bots, and command bots don't support slash commands. Wait, what? That's right, command bots don't support slash commands, at least as easily as they did for PyCord. Instead, they make use of text commands, which by comparison just suck ass, because there's no autofill and all your arguments are just in plain text. I almost went for it, but life without slash commands just suck, so I switched back. And instead, I switched from using a command bot into a client, which are what bots are implemented from. But with a client, we have a way of creating slash commands by registering these app commands. In order to register these app commands, we need to add them to something called a command tree, which is basically like the bot's list of commands. Whenever we get our command tree, it by default has a list of all commands registered in Discord servers. We can add and delete functions or commands by modifying the command tree with its methods, and then syncing it back up to Discord servers once the bot is online. Now, I was stubborn in keeping my commands organized like we did with cogs, and so with a lot of fiddling, I ended up creating my own command groups class. This abstract class just has a basic setup function that goes through a list of commands in this command list that we instantiate in each implementation. And these commands will be added to the command tree that we pass in. The parameters we give to each command, by the way, is just to make the command server or guild specific, much like I did in PyCord, which I suffered a lot with back in my first video, if you want to go check that out. But the setup for every command group is called in our main add commands function with its own line for each setup. Now for the actual commands. They are no longer part of the main cog class, or I guess group class now, and are instead defined globally. I originally didn't want to do it like this because I wasn't sure how I was going to maintain the reference to my bot object in a nice manner. But then I realized I could get it from the command parameters object that is passed by default. Then I just take these function names and put them in that group's command list during initialization. Sick. Now that we've refactored, let's get on to adding all the speech to text stuff. I created a simple class for that model, then inside of my voice cog, I would use the Discord's extension specific implementation of their voice client and save it to their specific wave sync. Now, when I tested it, it would only stream in audio as I was speaking, which is perfectly what we needed. That tells me every time I speak, this write function in the sync is being called to write audio into the audio file. But then I realized that with that sync, I still didn't know when I stopped talking, only when I was. It's not like I had an event that would tell me when I've stopped talking. Not only that, but if I talk while the AI is deciding whether to respond or continue listening, and if the AI decides to respond and clear the audio file of its listened speech, I'm going to also end up clearing the speech that was being recorded and hasn't gotten a response yet. So I needed a solution where the audio was being handled in a way where I easily track the data being transcribed. That's when I stumbled upon this post where someone made a speech to text bot. What this bot does is take everything you've been saying in a voice call and print them to a text channel at regular intervals. It has no regard for if you're still talking, so it's not exactly what I was looking for, but I got a lot of inspiration from it, so I know what I needed to do. They have this custom sync implementation, which writes to a byte buffer instead of a file directly. They also have an additional function which removes previous audio data up to a certain point. Down here on a loop, they continuously check the amount of audio data, and if there's currently more than 5 seconds of untranscribed audio, they track the index of the last byte that will be sent for transcription, transcribe everything before that, then forget everything up to that index. This idea could work for me. I can also remember the index of the last byte I was sending, write all the bytes before it into a file, send that into my speech pipeline, and then if I get a response, clear everything up until that last byte. Otherwise, continue adding to the buffer. Another thing that they did was run that transcription loop in another thread so the bot can continue doing other stuff while this happens simultaneously. Now, my solution doesn't exactly involve creating a new thread like they did, but I realized that I didn't have to do everything in sequence, and instead I used a 1-second timer that resets every time we receive an audio packet from Discord. But if the timer runs out before we receive another packet, then our callback function is ran, which will do everything I had just described before. I tested along the way to make sure things were working, and after fixing up all the minor bugs, it finally worked.
We're so close. I can feel it. I can feel it.
Hey there, can you hear me? Yo, YouTuber who dis?
Oh, we fucking got it.
Now, I'm not finished just yet. I mean, the current implementation can only really handle one speaker in a conversation, which is completely fine for the moment. But more importantly, right now, my text-to-text AI will try to respond no matter what, because I haven't prompted or trained it to remain silent whenever it thinks it shouldn't interrupt just yet. This is a bit of a problem because transcribed text is sent to it on every pause, not necessarily at the end of dialogue. So I need to retrain my model and add support for silence. I decided to hardcode the string no response. As a response, it should send when it decides to remain silent. If I see this in my response, I will skip writing to the Discord text channel and the TTS step entirely. The audio buffer in the sync will also not be modified, and the message history will not track that incomplete dialogue. If we do get a response, everything will just behave as normal. Okay. As for the actual AI, I need to make a new dataset. I decided I would modify the script that turns a multi-turn dataset into a single-turn dataset that I made a while back, and every time it would make a new entry in the dataset, it also adds another entry where the latest user input is cut by a random amount of words, so it hopefully no longer looks like a complete line of dialogue. Then I would have the AI respond with no response. I applied this to my own Discord dialogue data I made in the previous video along with this script, and then I trained an OpenAI model using it. It now doesn't respond to incomplete lines, but it also has a habit of just donowalling. I gave it a try in the voice call, and it seems to do the same thing. What do you mean what I mean by that? What do you mean what do I mean by that? I just want to joke. Okay, well, anything else you want to talk about?
Not really.
Damn, okay. Okay. That was a conversation, I guess. But overall, the behavior is a lot better and easier to talk to. I'll just have to continue training to get it to respond more when I want it to. But for now, we've completed our entire speech pipeline, and now we can talk to our AI, soon to be VTuber. Anyways, while I document and push my changes, make sure to leave a comment down below on what I can improve on. Remember, the code to my entire project is linked down below. In the next video, we're finally putting the VTuber in AI VTuber, so subscribe to not miss out on that. Let me get up and out of your way. See you next time.